What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about embedded systems communication such as 5G, narrowband, baseband radio, SIM cards, and Zigbee. Let's talk about 5G. So 5G, this is the 5th generation technology standard for broadband cellular networks, which cellular phone companies began deploying worldwide in 2019, and is the planned successor to the 4G networks, which provide connectivity to most current cell phones. 5G networks are predicted to have more than 1.7 billion subscribers worldwide by 2025, and like its predecessors, 5G networks are cellular networks in which the service area is divided into small geographical areas that are called cells. All 5G wireless devices in a cell are connected to the internet and telephone networks by radio waves through a local antenna in the cell, and the new networks have higher download speeds, eventually up to 10 gigabits per second. In addition to 5G being faster than existing networks, 5G has higher bandwidth and can thus connect more different devices, which improves the quality of internet services in crowded areas. And due to the increased bandwidth, it is expected the networks will increasingly be used as general internet service providers for laptops and desktop computers, competing with existing ISPs such as cable internet, and also will make possible new applications in IoT and machine-to-machine areas. And some of the key advantages of the 5G network are the following. It has expanded communication capabilities, thus increasing the capacity to connect more people and devices. It has a lower latency of 1 millisecond, which will enable users to encounter fewer lags and delays when attempting to access data through the network. And it has higher rates of data, which can range between 1 and 10 gigabits per second, thus enabling users to download and game quickly. Next, let's talk about narrowband. So narrowband signals. These are signals that occupy a narrow range of frequencies or that have a small traditional bandwidth. In the audio spectrum, narrowband sounds are sounds that occupy a narrow range of frequencies. In the telephony sector, narrowband is usually considered to cover frequencies 300 to 3400 hertz, which is also known as the voice band. Another component of narrowband is called narrowband-IoT or NB-IoT. And NB-IoT standards are based on low power, wide area technology developed to enable a wide range of new IoT devices and services. NB-IoT significantly improves the power consumption of user devices, system capacity, and spectrum efficiency, especially in deep coverage. NB-IoT low power consumption extends battery life to more than 10 years, which can be supported for a wide range of use cases. NB-IoT is also supported by all major carriers, along with chipset and module manufacturers, which can coexist with 2G, 3G, 4G, and 5G mobile networks. It also benefits from the identity confidentiality, entity authentication, data integrity, and mobile equipment identification. Next, we have baseband radio, and this refers to a signal at a very narrow frequency range on which data or information is superimposed and then transmitted. It is also called a low-pass signal since it can include near zero frequencies. In this sense, a sound waveform is considered a baseband, while radio signals often rated in the megahertz levels are not considered baseband. And telecommunication networks, as we now know them, they consist of 4 different parts. The first one is called a radio access network or a RAN. Then you have a core network, then a transport network, and then you have an interconnect network. And these networks carry 3 distinct traffic types, which are commonly referred to as planes. The control plane carries the signaling traffic. The user plane carries the user data, which is the content of communications. And the management plane carries the administrative traffic. The administrative traffic contains configuration and control commands for the RAN and core functions. Network security is critical to these planes because all 3 of them are prone to unique and diverse types of threats. There are serious issues in a pre-5G baseband baseband, including the ability to remotely turn on microphones and listen in, send all calls to voicemail, remotely execute code, and crash the device. It is now trivial to set up a fake base station and have phones connect to exploits, so users should ensure that they only load known signed good applications, that their phones have the SIM chip encrypted and password protected, and that they allow updates to the operating system, and that they immediately report any issues to their providers. Next, we have a SIM card, and this stands for Subscriber Identity Module. So a SIM card, this is an integrated circuit intended to securely store the International Mobile Subscriber Identity, or the IMSI number, and its related key, which are used to identify and authenticate subscribers on mobile telephony devices such as mobile phones and computers. A SIM contains a unique serial number, the IMSI identity number, security authentication and ciphering information, temporary information related to the local network, a list of the services the user has access to, and it also has 2 different passwords. It has a PIN for ordinary use, and then it has what is called a personal unblocking key, which is used for PIN unlocking. And there has been an increase in SIM jacking and swapping, which is when someone convinces an employee of a telecommunications company to move a legitimate user's IMSI number to a new SIM card for the attacker, and the attacker then uses this access to reset passwords and perform account takeovers. And then finally, we have what is called Zigbee. So Zigbee, this is an IEEE 802.15.4 base specification for a suite of high-level communication protocols used to create personal area networks with small, low-power digital radios, such as for home automation, medical device data collection, and other low-power, low-bandwidth needs that are designed for small-scale projects which need wireless connections. The technology defined by the Zigbee specification is intended to be simpler and less expensive than other wireless PANs, such as Bluetooth, or more general wireless networking, such as Wi-Fi. Applications include wireless light switches, home energy monitors, traffic management systems, and other consumer and industrial equipment that requires short-range, low-rate wireless data transfers. Its low power consumption limits transmission distances to 10 to 100 meters, line of sight, depending on power output and environmental characteristics, and Zigbee devices can transmit data over long distances by passing data through a mesh network of intermediate devices to reach more distant ones. Zigbee is typically used in low data rate applications that require long battery life and secure networking, and Zigbee networks are secured by 128-bit symmetric encryption keys, and Zigbee has a defined rate of 250 kilobits per second, making it best suited for intermittent data transmissions from a sensor or an input device. All right, so that was my quick little class on embedded systems communication, where we talked about embedded system communications such as 5G, narrowband, baseband radio, SIM cards, and Zigbee. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.